So last one, quadratic optimization. The process of finding maximum or minimum value is called optimization. So we're optimizing a solution because it's either going to give you a minimum or a maximum depending on what sort of real life consideration we are looking for. So we know this fact for a quadratic equation. We know the vertex has the x coordinate of this expression. Okay, so if we know negative b over 2a, we've basically found the vertex x coordinate. So what that means is if it's a concave up graph, if a is greater than 0, you get a minimum value of y at this x coordinate. Okay, at a is less than 0, so if it's a concave down graph, as you can see, we get a maximum point at that same coordinate. So it's still same coordinate, we're going to use negative b over 2a, but you just need to be able to tell, is it going to give you a minimum value or a maximum value by looking at the a value of the equation. So that's what we're going to be doing. So example 25, find the maximum or minimum value of the following quadratics and the corresponding value of x. Now do notice that when we say maximum and minimum value, we're talking about the y value, not the x coordinate. So once we find the x coordinate by using this formula, we do have to find the y coordinate. And you already should know how to do that, but if not, I will explain it. But you should know how to do it. Like, I want you to be able to understand what the processes are rather than, try to put it on your cheat sheet and then refer back to it, because it's going to be way too much time consuming. So it is really important that you understand how to get there, so eventually you're able to remember it all rather than trying to just copy it off a cheat sheet. So aim for that. Knowledge is key. So we have this coordinate, this quadratic formula that we're working with. So first step is for you to locate your x coordinate for the vertex, because that is either going to give you the minimum or the maximum. So in order to do that, I need to identify my a, b, and c. So let's do that. 1, 1, negative 3. So therefore it'll be minus 1 divided by 3 times 1, so that'll be minus 1 divided by 2. So that is my x coordinate. Now, is it going to be a maximum or a minimum? So in order to tell, you just look at your a value. My a is greater than 0, it's 1, so therefore it's going to be a concave up graph, meaning that one's going to be a minimum. That's how you tell. Okay, again, you can try to remember it. If a is greater than 0, you get a minimum. A is less than 0, you get a maximum. Or you can just simply, as I did, try to draw a situation and figure out if it's a minimum or a maximum. So now we're going to be looking for a minimum. I know the x coordinate of that minimum, so basically all I need to do is find the y coordinate for it. In order to do that, I just sub it in. So in the y equation, I'm going to substitute my x coordinate that I'm looking for, and then I will get my y coordinate. So anytime I see an x, I substitute. So I'm just copying this formula, if you haven't figured that out. And then every time I see an x, I put in my x coordinate instead, a number instead. So I'm just going to borrow a calculator to do that. So I'll do that in my head. Make sure you get a bracket around those. So I get minus 13 over 4. So find the maximum or minimum value. So I guess your answer is minimum is at, and I'll just write it as a coordinate to make my life easier, minus half and then minus 13 over 4. That's my minimum. And then let's do B. So same process. First I identify my A, B, and C. Now notice that it's not in order, so I need to kind of identify my A, B, and C very carefully. So make sure you do that. Okay, now I begin. So x coordinate is always going to be negative b over 2a. So when there's a negative divided by negative, it becomes a positive. And I need to figure out if it's a concave up, concave down graph. So my a is less than 0, it's negative 2. So it's going to give me a concave down graph. So whatever that point is going to be a maximum. Okay, so how do I find it? I just substitute my x coordinate in to find my y. Anytime I see an x, I sub it in. Now I'm just going to borrow the calculator. And then I'm going to write maximum is at, as again, a coordinate. I find that easiest to read. Done. Okay, so now we've got a problem-solving question, as well as, I'm assuming, an optimization question. So it's a bit of a combination of the 2H and 2G. So let's have a look. Gardener has 40 meters of fencing to enclose a rectangular garden spot, okay, where one side is an existing brick wall on the diagram, as you can see. So we're pretty lucky because we have already a diagram and we can kind of label on top. But sometimes you might not be given a diagram, so your first step would be to draw that sort of diagram. Suppose the two new equal sides are x centimeters long. So they've already decided the x centimeters. I'm just going to call that x is the width. Okay, so meters in this case. So I've got x meters, and then we need to figure out, I guess, that. We should easily be able to figure out because we've got this fact. Gardener has 40 meters of fencing to enclose that much. So all of this, so x meters plus whatever that is, all adds up to 40. So if I write that in another way, it's going to be 40, take x, right? I've already got x meters there. Take another x, which can be simplified down to 40, take 2x meters. So that's what this length is over here. So I've figured out the length of that. So it says show that the area enclosed is given by blah, blah, blah. So area is what we're aiming for. It's a rectangle, so it's length times width. So let's have a think. Length, I just figured it out using some maths. So 40 take 2x, bracket around it. Width is my x, so that's what we're aiming for. It looks pretty similar. I just need to make sure that it looks exactly the same. So instead of having the x at the back, I'm just going to bring it forward. And then I don't have to bother expanding it or anything at all, just because that's what they wanted us to show. I just showed it. Done. Now this meters squared is just the units. If you haven't really thought about it, that's just what it is. It's not a part of the equation, as in like the variables. It's just the units. This area. Okay, so now I'll have a look at B. Find the dimension of the garden with the maximum area. They obviously want to optimize the solution and have it like maximum area because they want to be able to use as much area for the garden bed, garden plot. So they want to maximize the area. So we want to do that. In order to do that, I use the maximum coordinate, the vertex, negative b over 2a. Just double checking that it's right. I need to, I guess, identify my a, b, and c, so I need a quadratic formula. So I'm going to go back and expand my formula. Okay. And then I should be able to identify my a, b, and c. C is 0, and then tuck it in here, negative b, so I get 10. Okay, so my x is 10, so I just need to find the y. Do I need to even find the y? Not really. I guess I just need to find the dimensions. I found the maximum, I found the, I don't know, vertex, the x coordinate for it, so I guess I need to just find my length is. So my width I found is 10 meters. What's my length? Well, there was a formula for it somewhere. Here's the formula. This is my length. So I'm going to go 40, take 2, lots of 10, which is 40, take 20, which is 20 meters. So I'm going to write my answer in a worded format. So therefore, dimension of garden of maximum area is 10 meters by 20 meters. Now, in another kind of way to show me that this is a maximum area is just to comment on the fact that A is greater than 0, A is less than 0, which will give me a concave down graph, which will give me a maximum. So if you're able to fully state that as well, it proves us that it's a maximum area, because, you know, you could have technically told us this, but technically you don't actually know if it's a maximum or a minimum. So what this kind of shows us is it's a proof of that, you know, and you've shown the knowledge that it is a maximum area. And that's it, really. You've done it.